I'm digging into my archive to update videos and add a bit of pizzazz. This time round, I'm revisiting my chats on world-building species. I'm looking at the similarity between bats and my fictional species, Todaribrae. Here's how I'm transitioning the science of Mexican free-tailed bat physiology to a fictional life form. My Drifting Amalgams universe has a planet with a red dwarf star. Consequently, I looked at world-building species with keen night vision. Since I alter Earth-based life forms to create fictional species, bats seem like a good starting point. There are many types of bats though, so how to choose? That's when I stumbled upon a bit of science trivia. The horizontal flight of Mexican free-tailed bats reaches 160 kilometers per hour, or 100 miles per hour, making them one of the fastest animals in the world. This feat is made more amazing by the fact that this small mammal is no bigger than a human hand. Sounds like I have my baseline species. Noting some of the physical features that I'll want to keep, my Todaribrae have a bat body, dark vision, fast flight, and a comparatively small body. Like their bat baseline, Todaribrae have long wings to facilitate fast flight. I've also written their wings to be like bat wings. Stretch across 4 bat fingers, their wings are a layer of skin that can be spread and manipulated. This living skin incorporates blood vessels, nerves, and tendons, allowing bats to make micro adjustments in flight and affect lift. Essentially, they row through the air, adjusting the movements of their fingers to quickly change direction. The strong chest and back muscles power their upstrokes and downstrokes, which provide thrust and lift. It's a lot like swimming. The uniquely strong muscles of the Mexican free-tailed bat allow efficient and long-lasting flight. They also help in climbing with the aid of the bat's thumb, an appendage with a sharp claw that extends slightly above the wing. Before I add a few of my own touches to world-build this species, I want to talk a bit about bat tails. Tail membranes are a stretch of skin that connects a bat's otherwise independent tail and legs. This feature is thought to affect maneuverability, and there's some research suggesting that this tail membrane allows bats to stop quickly. The free tail in Mexican free-tailed bats means that these particular bats have a reduced tail membrane, which likely accounts for their increased aerodynamics. To reflect the traits I'm adapting from the Mexican free-tailed bat, I'm giving the Todaribrae some key physical stats, namely high speed and endurance, especially compared to the rest of the species in the Drifting Amalgams universe. So far, I've pretty much copied the Mexican free-tailed bat's traits. Now it's time for the creative license that makes this an exercise in world-building species. Colloquially, the Mexican free-tailed bat is known as the guano bat. This is because their roosts produce over 18,000 metric tons of urine and guano per year. With high levels of concentrated waste come high levels of toxic ammonia. But, biologically, Mexican free-tailed bats have an efficient ammonia filtering system, likely related to their respiratory tract mucus. These bats exhale ammonia when they move from highly ammoniated to normal air. This is fascinating, but remember that I'm world-building species that are highly technological. It's not enough to suggest that they are tolerant of their own waste. I mean, a narrative detail about people who don't think bathrooms stink is pretty mundane, but guano has been used for fertilizer and explosives. So what if one of the most valuable resources of my Todaribrae species is their own waste? A substance they refine with no need for ventilation or masks. This would allow them to trade in fertilizer or even rocket fuel made from a base material they could easily control. From sewer to refinery to off-world buyer. Another interesting trait of the Mexican free-tailed bat is their sense of smell. Because maternity colonies are dense, mothers need a way to find their pup for feedings. To do this, they rely on a combination of vocal and olfactory cues, recognizing the smell of their own pups in a crowded cave. Again, this trait isn't necessarily helpful for a modern culture, but being able to smell a specific person in a crowded room? Now that's interesting. So, my Todaribrae will have a strong sense of smell that allows them to recognize those familiar to them. Additionally, they'll be able to anticipate some behaviors based on shifts in hormones they can smell. This is a world of many species though, so only smells they are familiar with will register in this way. You may be wondering about echolocation. I took some creative license with this one. I decided to fully replace this trait with keen senses for gravity and magnetism. Aaron finished his rebuild of the Todaribrae model recently, so I get to show off a couple features I mentioned. The wing of the Todaribrae is a layer of skin that stretches over finger-like structures. Their wingspan is well more than their full height, allowing them greater speed than other species. This feature is complemented by their aerodynamic free tail. Also dexterous, Tadari Brae have arms and wings that protrude from the elbow. Their hands, which have a primary and secondary thumb, are used for fine work. But the danger of damaging a wing during handiwork has resulted in an evolved wing that folds in to sit along the back of the humerus. That said, I try to avoid overpowering a life form when world building species, so their wing and tail membrane can still be easily damaged because of how thin they are. Both membranes are very important for these species' survival, so they do heal quickly. Finally, the Tadari Brae have external sensory organs. Although their appearance is similar to horns, these organs allow Tadari Brae to sense gravitational and magnetic forces. Because of the ability to sense gravity, stealth technology is ineffective around the Tadari Brae. However, their strong sensory perception makes them susceptible to sensory overload. Similarly, being on planets with strong magnetospheres drives them insane. From bat science to bat-like fiction, I've created a versatile species with many gifts. Until next time, stay curious.